All right, absolute value equation. So we just talked about absolute value.
Oh, these numbers are not like on Blue Cross.
Yeah, they don't exist yet. It's happening now. So we just talked about absolute value. We said absolute value is how far a number is from zero, or its distance from zero. So mathematically, if you want to, you can, yeah, just to help yourself. It's the distance you are from zero. So it's how far you are from zero. You can draw yourself a picture if you like it up here, or just write down how far you are from zero. And whenever we measure distance, we always use a positive number, because I wouldn't say, oh, I traveled negative 10 feet today, right? If I moved forward or I moved backwards, I'm just saying I moved 10 feet. So our absolute value is always telling us to find a positive number. So because it's distance, it's a positive number. If I'm finding the absolute value of negative 3, it's just how far I am from 0. So since I'm 1, 2, 3 spaces away, that's why my absolute value of negative 3 becomes positive 3. My absolute value of 5 is just 5 because I'm 1, 2, 3, 4, 5 spaces from 0. So it's basically a big fancy symbol and a big fancy word to say make the number inside positive. You ready to see it in math? No, it's Monday morning.
What?
You ready to see it as math?
Sure.
Sure. All right. So my first example says the absolute value of x minus 6 equals 4. So it looks kind of similar to problems that we've had before. The only difference is now I have these two absolute value bars here. So the first thing I always want to do is make sure that the absolute value is all by itself on one side of the equal sign, so that there's nothing else multiplying, there's nothing else adding or subtracting, it's just an absolute value. Because this one just is absolute value, I'm ready to start solving. So in order to solve, I'm going to take the equation, and I'm going to take the inside of the equation, this x minus 6, and set it equal to 4. But I'm also going to take that inside x minus 6 and set it equal to negative 4. So it's basically like two problems in one. I'm solving for the positive answer and the negative answer, because I know if I had just a 4 inside these absolute value signs, the absolute value of 4 is 4. If it was negative in here, I would also get the absolute value of negative 4 equals 4. So I have to solve for both answers, the positive and the negative. And then at this point, you're really good at these equations, right? If I'm subtracting 6, I add 6 to both sides, and I end up with x equals 10 as one answer. And I'm going to add 6 to the other side. And I'm going to end up with x equals 2. So I'm going to have more than one answer now, because I'm solving more than one equation. So you're still using all your same steps from solving all your other equations. The only difference is we've got to write two separate equations, one for the positive answer, one for the negative answer.
And both of them are right?
Yep, and both of them are right. They're both solutions to the equation. And I can check myself. If I wanted to check myself, I could say, okay, I know that x is 10 here, so I go back in and I say 10 minus 6 equals 4. And I just replaced my x with a 10 because that's what we said x was equal to. And then if I do 10 minus 6, I get absolute value of 4 equals 4, which means I end up with 4 equals 4, and this is true, so I know I'm right. Say that again? The bars? In the original equation.
But the last thing, like the last slide,
Mhm.
is that absolute value equals what?
Positive numbers.
Positive.
Yep. Positive numbers.
Oh my gosh, imagine if you wrote down like all the notes, but you forgot you were recording. That'd be like horrible.
Yeah.
Like you'd have to do everything again.
So what if I gave you the absolute value of 3x plus 1 equals negative 5? I'm going to make sure my absolute value is all by itself, right? And it is. There's nothing else besides that absolute value on the left-hand side. So I need to write two equations first. I'm going to I take my inside, 3x plus 1 equals negative 5. Wait a second. So I made sure my absolute value was all by itself. But what did we just say absolute value was? Always a positive number. What the heck's going on here? They're trying to trick us. Is that a positive number? So can an absolute value be a negative 5? No. So look at that. I don't even have to do anything. This one's done. There's no solution here. They were trying to trick us because I cannot have this negative 5 can't happen. I can't have an absolute value equals negative 5. So there's no solution because an absolute value can't be negative. So if at any time you see an equation where the absolute value is equal to a negative number, you don't have to solve that. There's nothing that we can do because we can't have a negative number for an absolute value. So you're done. There's no solution. How do you feel about these?
They're good.
They're good?
They're not bad.
Mm-hmm. When we're done, yeah. All right, what if I asked you, I'm waiting to see those pencils stop. I don't want to move on too fast. What if I said try absolute value of x minus 1 equals 4 and the absolute value of 3 plus x equals negative 3?
What do you do first?
You take it out of the mix.
Yeah, take it out of those absolute value, make two equations.
I'll do it.
Yeah, you would.
Witness.
That is.
So you also have to solve this equation that x minus 1 for negative 1. So we went through it two equations. We were like 1 plus x minus 1 equals 4. And then see how we get 4 and we can also get negative 4. So you keep the int. So this that's inside the absolute value stays exactly the same. And then just change the int to also.
Wait, so what about the negative point?
Yeah, so the left side stays exactly the same. It's the right side that we're going to change. Yes. So I'm going to end up for that first one. Oops. If I'm getting rid of my absolute value, I'm going to go x minus 1 equals 4 and x minus 1 equals negative 4. So I kept what was inside the absolute value. The x minus 1 stays exactly the same in both equations. X minus 1, x minus 1. It's the 4 that I'm changing. This 4 becomes a positive 4, becomes a negative 4. And then I solve both of these.
Excuse me?
Yep.
Is the second the one with the negative 4, is that one wrong? Because it ends up being the negative?
Only if, so it's in the situation where we have the absolute value equals a negative, that's our no solution. So
But
this,
I thought, variable can't be a
a variable can be negative. We just can't have that the absolute value equals a negative, but because in this first one, I got rid of the absolute value signs, I can have a situation where my equation equals a negative, that's totally fine. I just can't have that the absolute value symbols equal in negatives. But I got rid of the absolute value symbols, so it was okay for me to write this first equation, x minus 1 equals 4, and the second one, x minus 1 equals negative 4. And then I'm just going to solve these. So I'm going to add 1 to both sides, and I get x equals 5 is my first answer. I'm going to add 1 over here too, and I get x equals negative 3. So I think the trickiest part of this is writing the two equations. Because once you have the equations, you're good at solving regular equations. Ready to spice it up a little bit? Absolute value of 3x plus 9 minus 10 equals 4. What's different?
Gotta have two numbers on the outside.
Yeah, I've got this minus 10 hanging out next to my absolute value, right? And I know I need my absolute value all by itself. So before I do anything else, I've got to get that absolute value all by itself. But you're good at how do I get rid of a minus 10? Yeah, so I'm just going to get rid of this 10. I'm going to add 10 to both sides. And when I do that, I'm going to end up with the absolute value of 3x plus 9 equals 14. Now I'm going to check. I don't have an absolute value that equals a negative, so I know I can solve this. My absolute value is all by itself. So now I can write my two equations. So I keep my inside my 3x plus 9, and the first one's going to equal 14. And then I'm going to do it again, and I'm going to have 3x plus 9 equals negative 14. So a positive number, a negative number, and then I'm going to solve. How do I get rid of a plus 9? I subtract it, right, on both sides. Subtract it, and you can, totally up to you, if you want to solve one equation all the way until you get x and then solve the other one, or if you notice that you're going to be doing the same thing, you can solve them both. It's up to you. That's just a personal preference. So then I get 3x. 3x equals 14 minus 9 gives me 5. And then this one I get 3x equals negative 23. They're both negative, so I'm adding them together. And then I got to get rid of those 3's. To divide by 3, divide by 3, divide by 3, divide by 3. And I end up with everybody's favorite fractions. X equals 5 over 3, and x equals negative 23 over 3. You don't like those fractions?
No, like the calculus one.
Yeah. What about something like this, where I have 4 times the absolute value of 2x plus 7 equals 16? What do I have to do there first? Am I ready to write two equations?
No.
No, because I have a 4 there, right, stuck to my absolute value. So if I'm multiplying by 4, how can I get rid of it? I divide by 4, right? So I'm going to divide by 4, which is going to look weird, but it's okay. As long as I do it to both sides. Doesn't matter how weird it looks. So I divide by 4. That gives me the absolute value of 2x plus 7 equals 16 divided by 4. Gives me 4. Is that equation going to have a solution?
Yes.
Yes, it is, right? Because it's an absolute value equaling a positive, so we're going to keep solving that. So then my next step, get two equations in here, right? 2x plus 7 equals 4, and 2x plus 7 equals negative 4. See if I can get that. What do I have to do first? Get rid of those 7's, right? So I'm going to subtract 7. Subtract 7. You do it over here too. Which is going to leave me with 2x equals negative 3 and 2x equals negative 11. And then you're going to tell me to divide by 2. Almost. Divide by 2. And I get x equals negative 3/2. and negative 11 halves.
Really?
Notice how I wrote my answer? A little bit different, right? So it's completely fine. You can write two separate answers. X equals 5/3, x equals negative 223 over 3. Or if you're feeling fancy and you only want to give me one answer, you can just separate them with a comma and write the two answers. So it's totally up to you. That's also a personal preference. They're both correct. They're just different ways that we can write the same answer. What do you think? It's not bad? It's pretty easy. Yeah, it's just weird setting up the two, right? Yeah. What if, I'm going to skip the you do and show you, what if I give you something like that? Where an absolute value equals another absolute value. It looks weird, right? Absolute value of x plus 5 equals absolute value of x plus 11. Looks strange. But I'm going to do the same thing. So I'm going to take my first equation. First, I'm going to make sure my absolute values are all by themselves, so I'm good to go. I'm going to take my first part of my equation, this x plus 5, and I'm going to keep it exactly the same. And then for the first equation, I'm going to keep my right side of my equation exactly the same. I'm going to make it x plus 11. But my second equation, my x plus 5 stays the same. I'm going to make the whole thing negative, so I put it in parentheses with a negative sign. So it's the same idea where I take the inside of the left and set it equal to the positive and the negative of the right. The only difference is they made it look a little bit different by making them both absolute values. And then you're good at solving these. We got to get our x's on the same side, right? So I'm going to move my x over. Ugh, interesting. My x is going to cancel on both sides, and I get 5 equals 11. What happens when I have 5 equals 11?
That is not right.
No solution, right? Because 5 doesn't equal 11. What the heck are they talking about, right? So this is no solution, this part. And then when I'm solving my other side, the first thing I have to do is distribute this negative, which gives me x plus 5 equals negative times x is negative x, negative times 11 is negative 11. So now instead of subtracting x on both sides, in order to get rid of a negative x, I'm going to add x, right? Add x, I get 2x plus 5 equals negative 11. And I'm really good at solving these, right? Then I subtract 5 on both sides, subtract 5, and I get 2x equals negative 16. And I divide by 2, divide by 2, and I get x equals negative 8. So it's okay for one side of my equation to give me a no solution and one to give me an answer. That could happen too, where you kind of have a mix and match like that. But basically, you're always just taking the left side and setting it to equal to the positive and the negative of the right side. I think you can do it.